analysis of blood alcohol in concentration BAC in suspected DUI cases by using volumetric analysis. So here is my group members. We have HAZWANI HUSNA, Alya Natasya, ADRIANA SOFIYA, and SITI RAHMAH.
The alcohol causes very obvious organization as in effect, physical skills, and it can interfere with attention, perceptual functioning, and decision making while driving. So DUI, driving under influence of alcohol, is a significant public health concern worldwide, contributing accidents, injuries, and fatalities each year. Suran Warangya reported through the Age Malaysia. BAP Chairman Lim Wan Eng said that the data provided by the police showed that the road accident involved with DUI of trucks in 2020 is to 119, 2019, 39, 100, in 2018, 191, 2017, 212, and 2016 is 461 cases. So in response, law agency enforcement rely on accurate methods for determining blood alcohol concentration BAC, to establish legal proceeding and to ensure road safety. Volumetric analysis represent a cornerstone for forensic toolkits for assessing BAC levels in blood, BAC levels in suspected DUI cases. This methodological approach involves precise measurement of the volume of alcohol in blood sample, providing quantitative data crucial for legal proceeding and public safety enforcement. Over the years, various volumetric techniques have evolved, each with its advantage and limitation, from the classical dichromate oxidation method to the modern enzymatic assays and gas chromatograph. The field has witnessed remarkable advancement in and enhancing accuracy, reliability, and efficiency in BAC measurement. This video aims to delve into the theories, methodologies, and application of volumetric analysis in quantifying BAC levels in suspected DUI cases. By exploring the underlying scientific principles and practical consideration, we seek to elucidate the role of volumetric analysis in daily life, especially in forensic investigation and legal proceedings.
So now I'm going to smaller the scope of this topic. So let's give you guys an example, which is forensic investigation. So as for forensic investigation, in terms of DUI, the process for BAC analysis is first there will be a sample collection where a blood sample is taken from the suspect and handled carefully to maintain its integrity. And then second, there will be a sample preparation when the blood is processed to separate the liquid part, which is plasma or serum, containing alcohol for testing. And the third one is the volumetric analysis. There's two types of volumetric analysis, which is first gas chromatography and enzymatic assays.
So as for gas chromatography, it is highly accurate and widely used for BAC analysis. It separates alcohol molecules based on their volatility and affinity for the stationary phase within a column. Meanwhile, for enzymatic assays, it uses a specific enzyme that reacts with alcohol to produce detectable signals such as color change or fluorescence. Fourthly, quality control and assurance. Instruments are checked and calibrated regularly to ensure accurate results, and the labs will follow strict guidelines to maintain quality and reliability in testing. 5. The process for BAC analysis is reporting and interpretation, which is results are analyzed and compared to legal BAC limits.
So in Malaysia, the legal blood alcohol concentration, which is BAC, limit for drivers is 0.08%. This means that if a driver exceeds the BAC level or equal to 0.08%, they are considered to driving under influence of alcohol, which is DUI. It's important for the drivers to be aware of this limit to avoid legal consequences such as fines, license suspension, or imprisonment. Lastly is the legal implications. BAC results are important evidence in DUI cases, helping determine legal actions like charges or penalties. Also ensures public safety by identifying drivers who are over the legal limits. So what is so important about BAC analysis in DUI cases is first, BAC analysis provides an objective measurement of alcohol concentration in a person's blood. critical for determining impairment levels. And then second, it also helps establish whether a driver exceeds legal BAC limits, which is in Malaysia, like I said on the previous slide, 0.08%, which vary by jurisdiction but generally range from 0.08% to 0.1%. Thirdly, BAC results serve as a crucial forensic evidence in legal proceedings, influencing outcomes such as charges, fine, and sentencing.
Hello, I'm going to start explaining about the quantitative analysis of blood alcohol concentration (BAC) in suspected DUI cases using volumetric analysis. So let's get started. Here's an overview of how this theory and method are applied in this practice. So next is the volumetric analysis. What is volumetric analysis? It is known as titrimetry. Is a quantitative analytical method to determine the concentration of a substance by titration. Volumetric analysis involves in chemical reaction of alcohol, which is ethanol, with a titrant to measure its concentration in blood sample. For this analytical method, we have two methods, which is firstly is direct volumetric analysis, which is oxidation reduction titration. For instance, ethanol in the blood sample can be oxidized by a known volume of titrant, such as a potassium dichromate. In an acidic medium, the amount of the titrant consumed is proportional to the ethanol concentration. Secondly is the indirect volumetric analysis, which is BAC titration. Sometimes a BAC titration method is used. A known excess amount of oxidizing agent reacts with the ethanol, and the remaining unreacted oxidizing agent is titrated against a reducing agent to determine the amount of ethanol indirectly. Let's move on to the practical consideration, which is the first one is sample preparation. Blood sample must be properly collected, stored, and prepared to avoid contamination or degradation of ethanol. Secondly is accuracy and precision. Ensuring accurate measurement and precise calculation is crucial. Calibration of equipment and use of standard solution are essential. Thirdly is the interference. Other substances in blood may interfere with the titration process. Specific methods to isolate and remove such interference are necessary. Fourth is legal and ethical issues, which is proper of custody and documentation must be maintained for the blood sample to ensure legal validity of the test results.
Hi, for this part, I will guide you on the methodology for quantitative analysis of blood alcohol concentration or BAC in suspected DUI cases using volumetric analysis. Our objective today is to accurately determine the BAC in a given blood samples using volumetric analysis. Now let's begin with the procedure. Firstly, we will need to collect the sample collection, which is blood. Blood samples are collected using sterile syringes, then transfer the blood sample into a label container. Samples are carefully labeled with essential details such as individual's name, date, and time of collections. Next, we will prepare our reagents. Step 1. Prepare a 0.1 mol per liter potassium dichromate solutions by dissolving 2.943 gram of potassium dichromate in distilled water and diluting it to 100 ml in a volumetric flask. Step 2. We have to use a commercial available concentrated sulfuric acid solutions. Step 3. Prepare a 0.1 ferrous sulfate solution by dissolving 2.781 gram of ferrous sulfate in distilled water and diluting it to 100 ml in volumetric flask. For the last step is to prepare the indicator solution by dissolving 1.485 gram of 1,10-phenyltoluene monohydrate and 0.695 gram of ferrous sulfate heptahydrate in distilled water and diluting it to 100 ml in a volumetric flask. Now let's set up the reactions. First, we have to measure 50.00 ml of blood samples using a volumetric pipette and transfer it to a conical flask. Then, we have to add 25.00 ml of 0.1 mol per liter potassium dichromate to the flask containing the blood samples. Next, we have to add 25.00 ml of concentrated sulfuric acid slowly while stirring to prevent splashing and excessive heating to the mixture. Last, we have to allow the reaction mixture to sit for 30 minutes to ensure complete oxidation of the ethanol in the blood samples by the dichromat. After the reaction is complete, we proceed to titration. So first is transfer the mixture to a titration setup and then fill a burette with 0.1 mole per liter ferrous sulfate and then add 2 to 3 drops of ferron indicator to the reaction mixture. And then we have to titrate the excess potassium dichromat with the ferrous sulfate solution from the burette slowly while shaking the flask until the indicator changes color. The end point is reached when the color changes from the yellow to green and finally a stable red color. And then record the volume of ferrous sulfate solution used. We have to repeat the titration 3 times to obtain accurate and precise results. Now let's take a look at the titration results. So this is the data we recorded. So the total average of ferrous sulfate we use is 18.87 ml. Now let's take a look at the chemical equations. So the equation 1 is for the oxidation of ethanol by dichromat in acidic medium, and for the equation 2 is for the dichromat reacts with ferrous sulfate. Now we can calculate the BAC from the titration data. So let's start with the initial moles of dichromat added. The initial moles of dichromat added to the reaction mixture are calculated using the concentration and volume of the solutions. Next, we determine the moles of excess dichromat using the BAC titrations, which allow us to find the moles of ferrous sulfate. Now, to find the mole excess of dichromat, we compare it with the moles of ferrous sulfate. Next is to find the mole of dichromat reacted. So we have to use the formula N initial dichromat minus N excess dichromats. Moving forward to find the moles of ethanol reacted in the sample, we compare with the moles of reacted dichromats. Lastly, we determine the mass of ethanol reacted in the samples. So for the conclusion is we have to calculate the percentage weight over volume of ethanol in the blood samples. So it is 0.1518 gram over 50.00 milliliter times 100 is equal to 0.3%. So the BAC in the blood sample is 0.3%. It is significantly above the legal limit in most jurisdictions.
Hi, moving to my part, which is the lab part, I will conclude this topic. Okay, the conclusion of the blood alcohol concentration, BAC, which is typically involved to determine whether the BAC level excess legal limit to driving or other activities. It is used in legal and medical contexts to assess the impairment and potential risk associated with alcohol consumption. It often determines the legal consequences such as fine, lesser sufficient, or even the criminal charge depending of the jurisdiction and the severity of the offence. Next, we go about the conclusion of methodology. Firstly, sample collection and preparation, which is highlight the significance of using appropriate blood sample collection method in order to preserve sample integrity. Then analytical method that using volumetric analysis method were used to determine the blood alcohol content, BAC, making use of accurate measurement instrument and standardized process. Okay, next, finding and interpretation. The measurement blood alcohol content, BAC, was compared to the legal threshold to apply to DUI cases in order to provide trustworthy information for decision related to the law and medicine, and the result will interpret taking statistical analysis and measurement error into the account. Lastly, the use of volumetric analysis for quantifying blood alcohol concentration, BAC, in suspected DUI cases proved to be reliable and accurate method. It precious in determining BAC level contribute significantly to the legal and medical field, ensuring fair and just outcome in cases involve alcohol impairment. Okay, that's all for our group. I hope you guys enjoy. Bye.